Right, I'm going to draw a cyclical quadrilateral. And I'm going to draw something through the center as well. All right, let's say that this is, I'm going to say that this is 50. All right, actually, I'm going to zoom in so I can see it better. All right. So if I said that this is 50 degrees, let me just write that in a different color. Okay, if this angle here is 50 degrees, can I know any of the other angles at the moment?
Yeah.
What can I know?
You can know that thing is this one. It's 100.
Oh, what's 100?
Oh, that one.
Yeah, this one. This is 100 because it's going to be double the one at the edge. Is there anything else I could work out? What do you think? What one? What other part? You need to be more specific. Good. Okay. So this is a full circle, isn't it? So if that's 100, this is 260. Okay. What do I know about this angle down here? Do I know that? What is it? Why is it 130? Okay, so there are two ways you could work this out, and that's one of them. This is 260, which means that this has got to be half of that because this is the upside down version of what we just did. Or this is a cyclic quadrilateral. So these two angles have to equal 180. See how they do equal 180? So both of those were okay ways to do it. What do you know about these two lines here? They're equal. So what do you know about these two angles? They're also equal, aren't they? What do you know about these two angles? They're equal. Do we have enough information to work them out? We do. This is 50 and 260. Whoa, hello. Which is what? 310. So then if these two angles are equal, how many degrees do I have left?
25.
They're 25 each, right? Because I've got 50 left because it has to equal 360. Divide by 2 means that these are 25 each. I can do the same with this, right? I've got 130 plus 100, which gives me 230. How many degrees do I have left? 130. Divide that by 2 gives me 65. Yeah. Because these are both radii. Oh, that's a good point. They might not be. Ooh, I've drawn that weirdly, haven't I? Okay, we need some more information. That's going to help, isn't it? All right. So you get my point. When you're given a piece of information, you can always work around and find more things out. All right, there's one more rule we need to look at. One more rule we're going to look at. All right. Let's zoom out. Is that enough to fit? Oh, geez, I've written way too much on one screen. Whoa. Oh, there we go. I didn't know you could do that. Let's save that. Yep. This bit, hang on. This bit, how does what become what? So this is double this, right? It's just upside down. It's the same as the 150. It's just the other version. It's upside down. I don't know if I can rotate this. I can't, I don't see. Right? So if you drew this upside down, that would be the 100 and this would be the 50. It's just the upside down version of it. Angle at the center, angle at the circumference. Okay, I'm going to get rid of this and I'm going to do one more rule for us. All right, so we already know this, don't we? So if I drew a diameter and I drew a tangent, what do you know about that?
90 degrees.
Okay, good. Diameter / radius to a tangent is always 90 degrees. But what if it's not a radius or a diameter? What if it's just a chord? Okay, oh geez, that doesn't even touch the circle. All right, so what if I drew a chord instead? So what we do know is there can still be some information that we can tell. If I then used this, sorry, I need to draw that better. I'm actually going to draw it differently. I'm going to draw it like this so I can do my chord where I had it before. Okay, so this is still a tangent. This is a chord, but they're no longer meeting at 90 degrees because this is not a diameter. But if I drew a triangle, and it doesn't matter where I draw the triangle, this outside angle here is always going to equal this angle here. Why am I getting so many glitches? This is so annoying. All right, the external angle here is always going to be equal, guys, listen, to this angle over here. And it's also true of the other side here. This angle over here is always going to equal this angle over here. Now, I've drawn it so that it looks like a equilateral triangle, but it doesn't have to be. Let me give you an example where it doesn't look like one and the rule still applies. So if I give you another circle and we do that exact same thing, I'm going to draw another radius, sorry, another tangent, another chord, and let's do this. So now it looks completely different. This external angle is still going to match this angle over here. And this external angle is still, although this looks quite almost like a right angle, doesn't it? We can't make an assumption, but these two angles are going to be the same. Even though they look like a right angle, should I say that they could be? How do I actually know that they're not? I actually know for certain that they're not right angles. How could I know that? This angle here and this angle here, they look like right angles. How can I be certain that they're not? Protractor?
Let's try.
What did we say about this? Okay, does this go through the center? It's close to it, but it does not say it goes through the center, okay? If this line went through the center, then this would actually be a right angle because we'd be following this rule. But I have not said it goes through the center, so therefore we know it can't be 90 degrees. It might be 89 or 91. It's probably pretty close because of the way it's drawn, but do not make that assumption. Now, this one is called the alternate segments theorem. And I must say, this is probably the one that people struggle with the most. It looks pretty easy here, but it's actually a lot more difficult to recognize when you actually have problems. Yeah, this one's probably the trickiest one, I think. All right.